My name is Marialena Nikolopoulou. I'm Professor of Sustainable Architecture and Director of the Center for Architecture and Sustainable Environment at the Kent School of Architecture. And today I would like to discuss thermal experience and the potential of our thermal experience as a design tool. We are all familiar with the challenges facing our cities: rising temperatures, flooding, intense overheating, and the urgency that we have in terms of getting mitigation measures and adapting our cities to climate change. However, at the same time, we also have the paradox of a universal style of architecture. So irrespectively of where we are in the world, irrespective of geographic or climatic location, we seem to be designing with an identical style. Very tall, sort of high-rise buildings made of glass, large areas of glass actually in climates that shouldn't be having so much glass in the first place, that need to be heavily engineered with building services relying heavily on air conditioning, heating and cooling, to enable comfort, thermal comfort for the actual inhabitants of the buildings and for the occupants living or working there. Cities are a complex system of interconnecting links. Individual buildings, urban blocks, roads, parks, transport systems, all affecting environmental quality, which in turn affect human health. However, against this complex background, people are an integral part of the environmental system. They are, in fact, the common thread. So it could be argued that understanding the importance of thermal experience in this context will enable us to use urban design constructively to improve environmental quality. But what actually affects our thermal sense? In the external environment, we have different parameters affecting the microclimate. Beyond temperature, we have solar radiation. And of course, we know that there are different components that influence solar radiation, whether the geometry from nearby buildings, vegetation, the spacing between the buildings will very much have influenced the conditions at different times of the year. And this will also affect use of a space. And here we see a narrow street in a Mediterranean island in the midday sun. We see that hardly any people walk by, and whoever wants to stop, they really have to sit very tightly together in the narrow steps, the only part where there is shade in the street. However, the same street later in the day, once the sun has set, completely transforms. We get completely different character for the area, with tables start appearing, coming out, and it has to be remembered that commercial proprietors are normally the first ones to realize the potential of using, improved microclimate. But we don't always get things right, and here we see the example of Fenchurch Street, the tower when it was first built. And we see, because of the shape, the curved shape of the building, at different times of the year, specifically in the autumn, we can actually see a different part of the day. It actually concentrates the sun when we have a clear day and directs the solar radiation at ground level across the street. But as I said, the specific time of the day, it's not just about having bright light. The radiation is so intense that it's actually led to burned carpet, as we saw in the news, metal melting, or even frying eggs, as we've got the example here. So there can be some disastrous examples there. And the solution, they had to actually install external shading devices to the building to prevent some of these radiation being redirected. A very expensive solution, which could have been installed at the very beginning, which of course it was suggested, but then due to costing cuts, they decided to remove it, which was a very expensive mistake, and then had to reinstall it from the very beginning. But then beyond the solar radiation, there is also the wind, which is a very important parameter in the urban environment. And we know, we can understand the basics. We know that when the wind hits a building, at the windward side, we have an area of positive pressure, and then at the leeward side, we have an area of negative pressure, which effectively is the one that's driving the wind. And we also know what's happening when we have tall buildings in this environment, and about 3/4 of the building at the height, we have the wind separating, with some of it going over the building and the rest of it being directed at ground level, where we actually see the increased wind speeds for the pedestrians, both at the center of the street and over at the corners. And if this is not investigated carefully, it can have some very negative results on the urban environment. Here we see the example of Bridgewater Place in Leeds, in an area, it's a very tall building in an area which is fairly low-rise building. And this area had problems with the wind pretty much early on, as soon as the building was erected. And you can see here how pedestrians even struggle to walk across the street at certain times. But it was not just the discomfort. Much more importantly, I mean, nobody would have believed that it could end up to sort of a lethal result when a 35-year-old man was killed after a lorry was actually blown over and landed on him. So some really unintended consequences, and quite grave, as was in this example. So as a result, and after a few years consultation and design strategy, they decided that Bridgewater Place will have to put wings in place to block winds and actually prevent these downdrafts from coming down at the pedestrian and causing these very uncomfortable or even dangerous conditions. So it becomes important, the thermal comfort, the thermal experience, and how we actually experience the places can actually have important role in this example, in the urban environment. We know that the external conditions and our balance, our internal balance very much depends on how much heat is generated by the body and how much heat we're actually losing towards the outside through conduction, convection, evaporation, etc. And once we reach this balance between losses and gains, it's where we are supposed to be in some kind of a state of thermal comfort. But what do we actually mean by thermal comfort? What is the actual definitions? One of the definitions is simply the absence of discomfort, which is not a particularly inspirational definition. Or the other one that is used by the ASHRAE, the American Society of Heating, Refrigerating and Air Conditioning Engineers, is the state of mind that expresses satisfaction with the thermal environment, with the thermal surroundings. Now, you can understand when an engineering body starts using in the definition words like state of mind, it is quite a complicated concept. It's not as straightforward. So this probably suggests why we have been doing research, various bodies around the world, various teams are actually doing research in thermal comfort for so many years, and we keep having new challenges. So very much where I would like to focus is, as I said, on people, on the pedestrians. So not just about the buildings and the spaces between them, but how do actually people engage with these spaces? How do they understand thermal comfort? And what are the parameters that at the end of the day actually affect their perception and evaluation in these areas? And much of the research, although it was spread in various projects, one of the biggest and the milestone project was a large European project we had looking at thermal comfort conditions in different cities across Europe at different climatic zones, from Athens and Thessalonica in Greece to northern Italy, Switzerland, Germany, and the UK in Sheffield and Cambridge. So what we were doing is we're actually studying the open spaces. We were monitoring the microclimate with physical equipment that we were actually carrying around, while at the same time carrying out interviews with the people found in these spaces, the people that were actually using these areas, trying to understand the different parameters that influence their behavior, how they actually use the space as well. And ultimately, we collected a large database of nearly 10,000 interviews around Europe, which gave us a large database which helped us to analyze the data and have some significant results. One of the interesting things was to actually highlight the effect of these microclimatic conditions on the use of space, not just through pictures and through observations, as I showed earlier, but actually trying to quantify this effect. For example, this is only one of the case studies. We were looking in Athens, in a neighborhood square, not in a tourist part of the city, and where we could actually see how the use of space varies at different times of the year. So, for example, in the summer, which is the red curve, we see that use is quite low during most of the day, particularly during the morning, sort of noon and early afternoon, which actually coincides with the hottest part of the day. But then in the evening, after sunset particularly, we really see this usage increasing significantly with many, many people coming outside, where by then it was actually outside was much cooler than the inside, and for them it was like an area of repose and being exposed to cooler conditions than the indoor environment. Then in autumn and winter, we see a reverse of this pattern, where, for example, heaviest use is during sort of a daytime and around noon, where it's also the warmest part of the day. And then as the days goes by, we see the profiles reducing significantly. So we see an immediate effect between microclimatic conditions and actual use of space, one affecting the other. Now, trying to look at the actual data that we collected in terms of the microclimatic data, and then some of the parameters in terms of how people evaluated the conditions. For example, here we have the actual summer and winter temperatures during the surveys, and we can see, as we would expect, the highest temperatures in the summer were in Greece, and the lowest temperatures were sort of in Germany and Sheffield in the UK. In winter, we see the reverse, as you would expect, sort of warmer temperatures in Greece, colder temperatures in Germany. But what is particularly interesting is when we look at how these conditions were actually evaluated by people on the street. So when we approached the people, we were asking them to rate their thermal evaluation on a 5-point scale from very cold to very hot. And as you would expect, there is a normal distribution where the majority of the votes fall somewhere in the middle. But what it becomes really interesting is when you look at the extreme of these votes. So what about the people that were voting very cold or very hot, effectively on the discomfort part of the scale? Now, remember, the temperatures, so the highest temperatures were in Greece. So if there is a direct relationship between stimulus and this sensation, the perception, you would expect the highest number of complaints about being very hot would be in the hotter climates. But in fact, we see that the highest number of complaints, we got them in Switzerland and the UK, which had significantly lower temperatures in the summertime. Similarly, looking at the colder part of the scale, at the very cold, you would expect that the highest complaints for very cold that you would find in people in places where you have the lowest temperatures, for example, like Germany and the UK, where sort of we have Sheffield there very low, or in Switzerland. But if you look at the highest numbers, you've got them sort of in Greece, where we have very cold votes being highest, and the UK, despite the fact that in Cambridge the conditions were not as cold. So there seems to be something happening where the one does not necessarily lead to direct relationship between sensation, stimulus and sensation. So we seem to have the power to actually adapt to our conditions and surrounding environment. And if we look at how we define adaptation, it could be broadly defined as the gradual decrease of the organism's response to repeated exposure to a stimulus involving all the actions that make them better suited to survive in such an environment. So in the context of the outdoor spaces, we have what sort of we call physical adaptations, various physical and behavioral actions that we can take to improve the fit between the environment and our needs, whether it's through clothing or moving, as I will discuss later on. There is physiological adaptation, which has to do with the physiology of the human body, and it's not as critical for the conditions that we were actually investigating in the urban environment. And then we have psychological adaptation, and that really becomes quite important as it really highlights that there are different parameters that come into play and actually influence our understanding and our evaluation of the condition as comfortable or uncomfortable. So, as I said, in terms of physical adaptation, the most obvious one, and one we are all familiar with, clothing, how we change our clothing. And as temperatures rise, we seem to be wearing clothing of less thermal insulation, as we can see here. Then we've got special variation. We can move from sun to shade. And as you can see here in the picture, there's a very clear cut of where the people gather, whether they want to be in sun or shade. And as the graph suggests, there seems to be a direct relationship. As temperatures increase, more people are seeking for shade. So in the context of designing an environment, it's important to provide this diversity, that there is this choice for people to choose different conditions for different microclimatic environments. But then it's really the psychological adaptation which becomes particularly challenging. As I said, in terms of the different parameters, naturalness is one of the most important ones in terms of why we're using the outside. We like the actual, the fresh air, sort of the breeze, all these very much naturally occurring changes in the urban environment. And it is for environmental stimulation that we're actually going outside, whether it is for a brisk walk or for a quick lunch in the park, to actually invigorate the senses, whether it is from the wind, the breeze, or the sunshine. So we actually seek this stimulation at different times of the year. And as we can see here, whether enjoying it in winter time or in the summertime, trying to cool down, stimulation is very much an integral part of the process. Another important parameter is our own personal experiences and expectations, and that depends on very much from which part of the world we are. For example, we often had, I'm from Australia, I like the heat, I'm used to the hot conditions. Or I'm from Germany, I'm used to the cold. So this really highlights that people's own experiences and expectations can have an important role, strong influence in how they will evaluate these conditions. Because in some ways, experiences also influence expectations and what is regarded as acceptable or unacceptable. But it is not only one's background, it is also the seasonal changes. For example, here we have in the graph the neutral temperatures for the surveys for the city of Thessalonica. And what are defined as neutral temperatures is really the temperature where people are reported to feel neither warm nor cool. So they are in a state of thermal neutrality effectively. And looking at this zone of thermal neutrality for 50% of the population, we can see that this, which is the zone for winter, varies significantly for the thermal neutral zone in the summertime. There is a big difference between the two. And this is purely down to the seasonal effect. And the effect of clothing on its own is not enough to account for such a big difference, but it really highlights the influence of experiences and expectations, along with what people would define as comfortable or uncomfortable at the end of the day. But how about design then? Is it possible to actually take some of these lessons and apply them in design? And the answer is yes, because by allowing for environmental diversity and environmental stimulation at different times of the year, we can provide more pleasant environments. And for example, shading is a solution that we are all familiar with, and it can actually be translated quite effectively in the outdoor environment. Whether it is like using Bobo Rush's ethereal umbrellas in Medina, or using art as a potential shading strategies, irrespective where you are in the world. If the need arises, there are different ways to create shading, or with the urban morphology, using the built environment, as we have here with arcades in Lugano, or as in Foster's example of Mazda City, whether they went back to sort of strategies for the hot, arid climate, and actually self-shading the streets to prevent the solar radiation from reaching the pedestrians at ground level. So giving emphasis on the pedestrian and designing around that rather than for the buildings per se, it can actually improve much more favorable environment for outdoor use. But we also have vegetation, again, a solution that we are all familiar with. And it can actually be integrated at different scales, whether it is at the building scale or as part of an urban network through streets and parks. It can actually improve microclimatic conditions significantly, whether it is through shading, through providing cooling from evapotranspiration of the plants, or even purifying, providing cleaner air. It is a satisfactory solution and increasing the naturalness of the place as well. Water, another solution, another strategy that we see more and more employed in the design of our cities, different forms, through air coolers, surface coolers, fountains, spray spots. We see that the vocabulary can be extended with different ways, and in most cases, whether is this interaction, it actually is very much preferable, and people always engage with different forms of water. But then we also have materials, and as architects, engineers, urban designers, we have a big palette of interventions and strategies that we can use, whether it is, as in the example here, of light color surfaces to reflect the solar radiation to avoid overheating to a degree, or using materials of different thermal heat capacity, depending on whether we want them to store the heat or avoid storing heat, and creating very different conditions. We can have different palette of interventions, or even technology through innovative materials, as we see here, the European Cool Roof Council, where different colors, different materials come with different properties with the innovative paints. So there is a big variety that designers can choose. So to conclude, and how we can actually create positive urban experiences, we have a large toolkit for environmental diversity, because effectively, if you think about it, the urban environment is like a living lab with appropriate building geometry, strategic location of materials, vegetation, water bodies, etc., are some of the parameters that can be involved. But we need to ensure that open spaces remain inviting for all people if we are to reduce over-reliance on air conditioning. So understanding people's thermal experience in urban spaces can really inform our vocabulary of independent physical interventions. And such knowledge can actually enable us to use design constructively to improve environmental quality, and why not even increase our adaptive capacity under climate change. But it is worth remembering that open spaces, apart from the fact that they play an important role in cooling our cities, providing clean air, helping us to escape of the heat of the built environment, they are not just climate regulators. They are an important amenity for the neighboring communities, supporting urban life, and ultimately ensuring social cohesion and well-being. Thank you very much.